On to section 6.4, page 452. The first two problems I'm going to do on this video would be questions 2 and 4. So the instructions, unless otherwise stated, all angles are a standard position. So 1 through 6, you're going to find sine, cosine, tangent when the terminal side of an angle passes through the given point. So in this case, the point -3, 2. A couple things about that. -3, 2. Here's our point. Okay, I'll use blue. Here's the triangle we're looking at. This is a distance of 3. This is a distance of 2. This is the angle we're looking at. Okay, so in setting this up, we've got we need to find sine of theta, which is equal to 2 over, well, we need to find our hypotenuse. That hypotenuse is, let's see, the square root of 4 plus 9, so the square root of 13. So sine theta is 2 over the square root of 13. Now, sine of theta in quadrant 2 is still positive, so we're good. Cosine of this angle theta is 3 over the square root 13. However, because cosine is negative in quadrant 2, cosine of this angle theta is also negative. So be sure and put your negative signs in there when you need them. There are points given for just simple things like the signage of your function, your trig function. Last is our tangent, just 2/3. And again, tangent has to be negative in that quadrant because it's sine over cosine, which is positive over negative. So tangent quadrant 2 is negative. On to number 4. For the point we go through is 4, -3. So we draw our lovely lines 1, 2, 3, 4. Here's that terminal side of our angle. Again, it's almost like drawing a reference angle, I guess. How do you know what angle to do? Some people get confused and want to find that angle there. Well, that's great and all, but we need to use an acute angle that ends or terminates at the x-axis. So back to this case, we've got, let's see, 4, 3, square root of 25. Right? That's our Pythagorean triple, 3, 4, 5. So quadrant 4, sine theta, again this being theta, that reference angle, sine theta is 3/5, but because we're in quadrant 4, that's negative. Cosine 4/5. Cosine in the first and fourth quadrants are positive, so we'll leave that alone. And tangent of theta, just 3/4. But because one of these two, sine or cosine, is negative, tangent is also negative. And that's how you do that. Now, I should have prefaced this whole video by clarifying, when you're given a point like -3, 2, or 4, -3, let me put This type of problem is not the unit circle. Okay? What I mean is, there are a few of you that get confused, and I can understand why. But the confusion is that once you set up your, let's say you went over 4, you went down 3, there are some of you saying the hypotenuse is 1 because you're used to the unit circle. The unit circle, yes, the radius of the unit circle is your hypotenuse, which is then 1. But that is not the case for these types of problems where you're given a coordinate, xy coordinate. And in those situations here, like 2 and 4, you have to find the hypotenuse using Pythagorean theorem. So that's my little spiel on that. I'm sure there's at least one problem like that on the test, so just be sure that you can identify the trig functions and find your hypotenuse.